Hey, Algebra 1 students, trust each of you did well on the test that you took yesterday. Just a few more lessons before we wrap up the school year. Trust everything's going well for you with this remote learning. Today we're going to get to lesson 101, where we're going to talk about multi-step absolute value inequalities. Now, this is actually a continuation of something we talked about just a few weeks ago from lesson 91. We just learned about basic absolute value inequalities. We'll see the same thought process as we're working through our lesson today. We just have a couple extra steps. That's why it's called multi-step absolute value inequalities. Just to review some things that we discussed before to get us thinking along the right process in today's lesson. Remember, what was absolute value? What was its definition? The absolute value of a number is simply its distance away from zero. Remember, your absolute value bars are the two bars that are side by side. You have pieces on the inside, and there could potentially be pieces on the outside of our question. The problems that we're facing today are the ones that said like the absolute value of x is greater than 5. What did that mean if the distance was more than 5 spaces away from 0? Or if a question says the absolute value of x is less than 4. What does that mean that the distance is less than 4? That affected how we set up our final answers. So what were the correct steps that we saw before for how to correctly solve an absolute value inequality? Those will be the same steps that we'll follow today in lesson 101. The first thing that you have to make sure of in your absolute value inequality is that you've isolated the absolute value expression. There cannot be any pieces on the outside of the absolute value, but you could have extra pieces on the inside with the letter x, but there can't be any pieces on the outside of your question. Once you have your absolute value inequality completely isolated, then you wrote, we called it a compound inequality. The compound inequality that we would write was dependent on if it was a less than question or if it was a greater than question. Well, again, what did it mean? If I was less than so many spaces away, I had to stay in between two numbers. So whether I had the less than or I had the less than or equal to, the setup always looked like this. And I call it sometimes the sandwich answer because I'm sandwiched in between the negative version and the positive version of my number. I can go up to a -5 maybe, and up to a +5, and that would allow me to stay less than 5 spaces away from 0 on my number line. The second situation that we had for our compound inequalities was our greater than. What did that mean? If I'm going more than so many spaces away from 0, I was in two different locations, so I was outside of two numbers for either of our greater than options. The format looked like this. We had x is less than, remember less than goes to the left. What kind of numbers go to the left? Negatives. So x was less than -a, or my other option if I go more than so many spaces to the right. Well, going to the right is the greater than symbol. Notice that's what I have there on the second part of my setup. And again, going to the right is positives, so it's greater than +a. The x's that I have in the setups, those just reference anything that's on the inside of the absolute value sign. It might say like x plus 2 or x divided by 3 minus 1. So our goal is still to solve for x like we saw before. We'll do the same thing in our lesson today. I have about 5 or 6 examples that we're going to walk through together about how to correctly isolate the absolute value and then the correct process for setting up our question. Make sure you're taking careful notes so you can follow these examples later on. So our first one, for absolute value of x plus 1 is less than 21. Again, step number 1, I have to isolate the absolute value inequality, or excuse me, the absolute value sign. The way to do that is just like if you're solving an equation. Do we get rid of the times 4 first or the +1? We would get rid of the +1. Well, how do I get rid of a +1? I would subtract 1. So 21 minus 1 gave me 20. So I have 4 absolute value of x is less than 20. The next step to get the absolute value all by itself is to get rid of the 4 that's right in front of it. To get rid of that 4 that's in front of it, it means multiplication. We would have to divide by 4. 20 divided by 4 gave me 5. So I have the absolute value of x is less than 5. Notice at this point of the question, the absolute value symbol is completely by itself. There's nothing else that's on the outside of the symbol. We've been able to move that over to the right side of the question. What kind of inequality do we have here? It's a less than. What did the less than setup mean? I was in between two numbers, and what two numbers would I be in between for this situation? -5 and +5. The x is what's in the middle because that's what's in the middle of our absolute value inequality. So -5 is less than x is less than 5. Now I do what I mentioned because I saw a couple of you do this on the recent test here. You're just saying -5 comma +5. There's not only two answers to this question, there's a whole range of answers. I can be any number in between -5 and +5, so I do need to write it on this inequality format like I'm showing you in order for you to correctly answer our question. Let's move to our next example. The absolute value of x over 2 minus 4 is greater than 2. Now, I want you to notice before we continue in this question, the over 2 at the beginning of the question is on the outside of the absolute value symbol. So that's something that we'll have to move over as we're working on step number 1. However, the first step to get the absolute value all by itself would be to get rid of the -4. To get rid of the -4, we're going to add 4. So 2 plus 4 gave me 6. So I have the absolute value of x over 2 is greater than 6. Well, how do I get rid of that over 2? That means dividing by 2. The opposite of dividing by 2 is multiplying by 2. So 6 times 2 gave me 12, and the absolute value of x is greater than 12. The absolute value symbol is completely isolated, so we can jot down our final answer. The absolute value symbol that we have, or the inequality symbol, is our greater than. What did that mean? If I'm greater than or more than so many spaces from 0, I was outside of two different areas. If I headed to the left, which is our less than symbol, I have to pass the -12. So x is less than -12, or my other option for the x. Notice I repeated the x again, just like we did in lesson 91. If I head to the right. Well, headed to the right is with our greater than symbol. And what number do I have to pass going to the right? It is our +12. Again, I can't just list the two numbers. I do need to show them in this kind of inequality format. I can't put it in my sandwich kind of answer because I'm not sandwiched between two numbers. I have to stay outside of two numbers on my number line. All right, continuing on our examples. -2, absolute value of x plus 6 is greater than or equal to 1. Like we've seen on the other examples so far today, the first thing we're going to get rid of is that +6. Well, to get rid of +6, we're going to subtract 6. 1 minus 6 is -5. So I have -2, absolute value of x is greater than or equal to -5. Now, don't let, oh, there's a negative there, so it is one of those no solution questions. That may not be the case because the absolute value symbol is not completely isolated yet. Still in front of the absolute value sign is that -2. Well, how do I get rid of that -2 right in front? I would divide by -2. Now, something should have just gone in your brain. Uh-oh, I just divided by -2. What do I have to do? We're going to reverse our inequality sign. Now the question says the absolute value of x is less than or equal to, and at -5 divided by -2. Well, the two negatives would make a positive, and I can't do 5 divided by 2. It doesn't come out evenly, so I'm going to go ahead and leave it in my fraction format, 5 over 2. The kind of inequality symbol that we have now is our less than. Notice on the right side is a positive number. So there actually is an answer on this question, so I couldn't just say no solution like maybe you were tempted to do earlier in the problem. The less than symbol means I need to stay in between two numbers. What numbers do I need to stay in between? -5 over 2 and +5 over 2. Notice as you're writing down these less than kind of questions, if you are actually able to write an answer, the two symbols that we have in the question are also at the less than symbols. That was something that we noted back in lesson 91. That's the same thing that we're going to see in our lesson today. The last examples that I would like to walk through with you have extra stuff on the inside of the absolute value. The first three that we've done only had an x. Well, now on the inside of the absolute value, it says x plus 3, or it says x divided by 2 plus 1. So after we isolate the absolute value sign and we split the question up, we'll have some extra solving that we need to do in our question. So let's see these three examples of how did we do that. The absolute value of x plus 2 minus 1 is greater than 11. Just like we learned in lesson 91, I cannot combine that 2 and then minus 1 because, they're not really like terms. The 2 is on the inside of the absolute value and the 1 is not. So what do I need to do first on this question? We need to get rid of the minus 1. I don't want any pieces on the outside of the absolute value. To get rid of the minus 1, we're going to add 1. So absolute value of x plus 2, that part stayed the same, is greater than, and 11 plus 1 gave me 12. The absolute value symbol is completely isolated. I cannot get rid of that 2 first. Again, some of you were doing that even though I said don't do it, so make sure you're listening carefully. You cannot get rid of the 2 yet because it's on the inside of the absolute value sign. What kind of inequality do we have here? It's a greater than. Well, greater than meant I had to stay outside of 2 numbers. What numbers did I have to stay outside of? Negative 12 and positive 12. Well, negative 12 is to the left. So I'm taking what's on the inside of our absolute value, the x plus 2, and I'm saying less than because it went to the left of negative 12. Or my other option was to go to the right. Again, I'm taking what was on the inside of the absolute value, the x plus 2, and I'm saying greater than because I went to the right, then I have to go to the right of positive 12. Notice both of these expressions here, both of these problems that I'm attempting to solve start the exact same way. They both start with that x plus 2. So don't change the inside part of the question. The only thing you're changing is that right-hand side, whether you're going left or you're going right in your question. The solving is going to be the same on both of these problems. We're going to have to subtract 2. So on the first one, negative 12 minus 2, it gave me negative 14. So I have x is less than negative 14. Or what's my second possibility? If I subtract 2, 12 minus 2 is 10, and I'm going to keep my greater than option. So x is greater than 10. Again, I can't combine these together because I can't be to the right of 10 and also to the left of negative 14 at the same time. So we do need to split these up just like we've done on the screen so far. 2 last examples here. We have the absolute value of x over 2 plus 3, and then plus 4 is less than or equal to 6. So we know by now, step number 1 is to isolate the absolute value sign. To do that on this question, I would subtract 4. So I have the absolute value of x over 2 plus 3 is less than or equal to, and I did 6 minus 4, which gave me 2. The absolute value symbol is completely isolated. Notice this time, unlike the earlier example that we did, the x over 2 is all inside of the absolute value sign. On the previous question, only the x was in the absolute value and the over 2 was underneath it. Well, this is not that situation, so I need to keep that in the original problem. The absolute value symbol is completely isolated now, so let's see what kind of question should we write. The inequality symbol that we have is a less than. What kind of problem do we have for less thans? If I go less than so many spaces from 0, I have to stay in between 2 numbers. What 2 numbers am I going to stay in between? Negative 2 and positive 2. So that's how I set up my question. Notice I still have the less than signs on both of those options. So negative 2 is less than or equal to, and this is what's in the middle of my question because it's what was in the middle of our inequality, the x over 2 plus 3, and then I have less than or equal to our positive 2. I have to stay smushed in between the negative 2 and the positive 2 on this situation. Now at this point, we can continue to solve for x because it's outside of the absolute value symbol. The first step to solve for that x would be to get rid of the plus 3. Well, to get rid of plus 3, I'm going to subtract 3 from every single part of this question. Negative 2 minus 3 gave me negative 5. Then I still have my less than or equal to and the x over 2. Less than or equal to, and on the right side, 2 minus 3 gave me negative 1. One more step to get the x all by itself. How do we get rid of that over 2? We're going to multiply by 2. Again, every single part of our question is going to get multiplied by 2. Now, we're only multiplying by positive 2, so I don't need to worry about changing any of the inequality signs. On the left-hand side, negative 5 times 2 is negative 10. Drop down the less than or equal to, and there's the x that we got all by itself, and again, my less than or equal to sign. To finish on the right-hand side, -1 times 2 is -2. So what does this mean? As long as I use some value of x that falls in between -10 and -2, that answer would work in this problem. There's a whole range of answers that I could use, not just one specific answer or two specific answers. There's actually an infinite number of answers that could work on this question. All right, got one more example for us to try today. I think we're starting to get this idea. We have the absolute value of 5x plus 2 plus 5 is greater than or equal to 22. We know by now, step number 1, we're going to subtract 5. So 22 minus 5 gave me 17. So the absolute value of 5x plus 2 is greater than or equal to 17. Again, do not get rid of that 5 or the 2 on the inside of the symbol until we have the question split up on step number 2. What kind of inequality problem do we have? It's the greater than. What was our setup on the greater than question? I was outside of two numbers. That means I need to be outside a -17 or a +17. -17, as we saw earlier, is on the left-hand side. So I took the inside part of my question. 5x plus 2 is less than, because it's on the left-hand side, -17. Or my second possibility, I took exactly what was on the inside of the absolute value, the 5x plus 2, and I could go to the right. What inequality symbol goes to the right? It's greater than or equal to, and on the right-hand side are the positive numbers, so +17. Once again, my solving process is exactly the same on both of the equations, or both of the inequalities. Step number 1, subtract 2. So on the first problem, -17 minus 2 is -19. So 5x is less than or equal to -19. Or on the second inequality, if I subtract 2, 17 minus 2 was 15. So 5x is greater than or equal to 15. What's your last step to get x all by itself? That's right, we're going to divide by 5. Now on the first inequality, -19 divided by 5, well, that doesn't completely divide out. 19 and 5 don't have anything in common, so I'm going to leave it as a fraction. I'd like you to do the same as well. So x is less than or equal to, sorry about that, -19 over 5, or what's my second possibility after I divide by 5, 15 divided by 5 is 3. So in our lesson today, we've gone over our absolute value inequalities again. Less than, I'm staying in between two numbers. Greater than, I'm going outside of two numbers. Now, two other things I just want to mention in case they show up on your homework tonight here. Remember we had those two interesting situations for our inequality questions, whether it be a no solution or an all real number. Well, what were those? If your absolute value is greater than a negative number. So these are the questions that had the negative number off to the right-hand side. Well, what's absolute value? It's distance, and distance is always positive. Are positive numbers bigger than negative numbers? Yes, that's always true. So that was an all real number. So if you're greater than a negative, it's all real numbers. What was the other situation? The absolute value of x is less than a negative number. Once again, if absolute value is distance and distance is positive, are positive numbers less than negative numbers? That is never true. And that's why that solution was a no solution on your question. So greater than negatives is all real numbers, less than negatives is a no solution.